All right, more vocabulary for us. Here we're talking about triangles, and you may or may not be familiar with this, but we have a theorem that says the sum of the measures of the interior angles of any triangle is 180 degrees. So, meaning that if I were to add up all three of these interior angles, angle 1 plus angle 2 plus angle 3 should always add up to be 180 degrees no matter what. Okay, let's see what else we're going to do here. We can also measure the interior angles of polygons depending on what size they are. Now, this theorem talks about convex polygons, and so if you'll remember convex, that meant that not only were they simple, that you start drawing and stop drawing in the same spot and closed, but you could also draw any line segment that you want to, and the line segment is completely encased in the figure. So in order for it to be convex. Okay, well, there are some rules for figuring out the interior angles of a however many sided figure that you have. So let's look at this first one here. We have a four-sided figure, and look what happens when we draw in the diagonal. There's only one diagonal here, because remember, diagonals go from a angle to the opposite angle, not right next to it, but another angle within the figure. In a four-sided figure, there is only one here. So it ends up, look what it does. It marks up the polygon into two different triangles. Well, what do we know about all the triangles? We know that all of their interior angles add up to be 180 degrees. So that we now have two triangles of 180 degrees each. In a five-sided figure, when we draw in the diagonals and make triangles, we end up with three triangles of 180 degrees. This is a six-sided figure, one, two, three, four, five, six-sided figure, and look what happens when we cut it into triangles. It's one, two, three, four triangles of 180 degrees apiece. So do you notice that this was a four-sided figure and it had two triangles? A five-sided figure had three triangles. A six-sided figure had four triangles. It's always two less than the number of sides that we have. That's what our theorem is talking about. The sum of the measures of the interior angles of any convex n-gon is n minus 2, so however many sides we have, minus 2 times 180 degrees, because that splits that into that many triangles of 180 degrees each. There's also a theorem that says the sum of the measures of the exterior angles of any convex n-gon is 360 degrees. So that might help us out from time to time also. Let's work some problems and see how this is all going to work out for us. Here we have some examples that say find the measure of the third angle in each of the following triangles. Okay, so we have this triangle here that has one angle of 70 degrees and one angle of 50 degrees. So if I were going to figure out what this third angle is, we know that each triangle has to add up to be 180 degrees. So I would have to subtract off 70 and subtract off 50 to figure out that that angle has to be a 60-degree angle. Part B, here we have another triangle, and they've given us a measure of 45 degrees. And do you remember what this measure is? This symbol means 90-degree angle. So if they have to add up to be 180, we can subtract off 90 and subtract off 45 to end up with a 45-degree angle. Now part C. Again, we have a nice right triangle in here, a nice right angle that makes that a right triangle. So if our degree measures have to add up to be 180, we can subtract off that 90-degree angle and subtract off the 30-degree angle they gave us to end up with a 60-degree angle. And finally, for part D, we have a 60-degree angle and a 60-degree angle. We want to know what this one is. We could take 180 minus 60 to end up with a 60-degree angle. So this would be an equilateral triangle. Remember that from our vocabulary from before? But it gets much more fun than that. Here is an example that says if 9x degrees and 5x plus 62 degrees are the measures of complementary angles, what is the measure of each angle? Okay, what do we know about complementary angles? We know that they add up to be 90 degrees. So whatever this angle is and this angle is, they have to add together to be 180 degrees. So 9x plus 5x plus 62 have to add together to equal 180 degrees. Now that is just an algebra problem that we can solve. 9x and 5x would be 14x plus 62 equals 180. And if we subtract 62 from both sides, we get 14x equals 28. And then if we divide both sides by 14, we get x equals 2. So we know what x represents now. Now, knowing that, we know that the 9x degree angle has to be 9 times 2, which is 18 degrees. And the 5x plus 62 degree angle is 5 times 2, which would be 10, plus 62, which would be 72 degrees. And because they are complementary, we can check ourselves and make sure that these add up to be 90 degrees, and they absolutely do. Okay, let's look at this one. Find x in the following figure. Okay, so we have a 1, 2, 3, 4, 5, 6-sided figure, and this is a convex polygon. So if I can use that formula that says n minus 2 times 180 is the degree measure of the interior of that polygon. So here, since we have 6-sided figure, that would be 6 minus 2 times 180, or 4 times 180, which would end up being, what, 720 degrees? So the entire interior here has to be 720 degrees. Well, we can figure out what this x is because we know the measure of all the other angles except that one. So we could take our 720 degree measure and subtract off. I'm going to start here with the 110 and go clockwise. So subtracting off the 110, the 105, the 142, the 122, and the 130. And when we subtract all of those, we should end up with a 111 degree angle. And finally, find the measure of the angle marked x in each of the following triangles. Alright, so here for part A, we have a 60 degree angle, an unknown, and over here we have 130 degrees. But this is the outside of the triangle, not the inside. But is there a way that we could figure out what this inside angle is? Well, absolutely, because what do we know about these two angles? They form a straight line, or 180 degrees. So that means this angle has to be a 50 degree angle to add to 130 and end up with 180. Now that we know two of these angles, we can find the third one, because 180 minus 60 minus 50 is going to end up giving us a 70-degree angle. So that x has to be 70 degrees. Now what about for this one? Well, this one is just a lot like the first ones that we were doing. Here's our x, and we were given a 65-degree angle and also a 90-degree angle. So what do we know about the interior angles of a triangle? They have to add up to be 180. So 180 minus 90 minus 65 is going to end up with a 25-degree angle.